Are you a stinky comp sci kid in his mom's basement? I know I've been there. So today we're going to introduce the best algorithm on the planet. So without further ado, this is Bogo sort. So I have two helper methods here. The first one will just kind of like print out the list of numbers, and then the second one, it's amazing. It'll simply tell us if it's sorted or not, which this is very, very important. So BOGO sort, what is it? So let's just take this array of like five numbers. We'll pass it in. And what BOGO sort essentially does is it'll randomly shuffle the array and then check if it's sorted. Thus, O of one, kinda, asterisk. So let's just code it real quick. We'll make a little counter to like, sounds wrong. We'll make a counter that will allow us to see how quick this thing is because it is so, so quick. So we'll do wall not sorted, not is sorted, nums. So it'll run until it's sorted. So technically, if you haven't taken a data structure and algorithms class, don't worry. Um, just know that this one algorithm here will give you 100. Put that for every one of your assignments, every one of your time complexity assignments, use this. Trust me. Yeah, just trust me. I know what I'm doing. I equals zero. So we'll just make a quick little for loop here to iterate over the nums like we always do. And we're using lovely Java today because I hate myself. Okay, so first we need to take the random index. So basically we need the index of where the number is going to be swapped with while not like losing the number, if that makes sense. So we'll take int random index equals, and we're going to cast it to int so it doesn't break because math.random inherently returns a float value or double, I guess. I've been using C too much. And we need to multiply this random because this only gives us between 0 and 1. And we're going to multiply this with the length of the array that we're passing in to give us our index. So next, we have to actually swap the two numbers. So we'll just make a temp value to store. So equals nums I, so the number that we're currently on. And then we're going to say that this nums I is equal to nums at that random index. So this temp here is stored. So if we overwrite this, it's still stored here. And then we're going to say nums at the random index is temp. Thus, we swap them. And we're just gonna, I don't know, how about we just like print out how many times this thing's run just to visualize it. I have a clip earlier that I deleted, which would have been hilarious. I actually did get this to run in one try, if you'll believe me. I have to print line. My God. Why does Java have to suck? The iteration uh, plus number of times run. And then we'll just do print nums. And yeah, that should be fine. So let's run it. So yeah, as you can see, it took 102 times to sort it. So let's just rerun it. Maybe it'll run a little faster this time. Hopefully. Hopefully. 115. Okay. So as you can see, it can be slow, but I promise you, see, look at this. Eight times to sort it. And see, this is so quick. Like this could be as quick as you'd ever want a sorting algorithm to be. Look, eight times. It's wonderful. So if you've never taken data structure and algorithms, then just use this. And if your boss ever comes to you and is like, we need you to sort a giant list of users, blah, 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 but just use this. Like it is fast. Ignore like whatever radix sort, bubble sort, ignore all that. Simply use this. Yeah, this is the world's best sorting algorithm. The end.